Okay, this is the P2 paper from January 2023. It's question number 10, which is the last question on the paper. As we can see, this is a methods of proof question. In particular, we're going to be proving by exhaustion because it says there to prove by exhaustion. So this is one of those questions where they've given me partial proof and they've asked me to carry on and complete it. So let's just talk about what exhaustion means. Exhaustion means if I'm trying to show something, if n is an integer, then 2n squared plus n plus 1 is not divisible by 3. What they've done is they've started off by saying, consider the case when n equals 3k. So that's a multiple of 3, and they've shown that it doesn't work for that one. If I can consider the case for n equals 3k plus 1, which is 1 more than a multiple of 3, and then I can do it for n equals 3k plus 2, that's 1 more than a multiple of 3. That's 2 more than a multiple of 3. The next one that I would do it for would also be a multiple of 3. So these three things together would constitute method by exhaustion because I'd shown all possibilities, all cases to be able to do it. So what we need to do is to just explain to the examiner what we're going to be doing here. So carrying on with my proof, I'd say, consider the case when n equals 3k. So I would say right now, consider n equals 3k plus 1. And what am I going to do? I'm going to sub that in. So I'm going to have 2 lots of 3k plus 1 squared plus 3k plus 1 plus 1. What does that work out to be? Take your time because it's a proof. So 2 lots of 9k squared plus 6k plus 1, if I'm squaring that. So you can take a little bit more time over that if you want to. Plus 3k plus 1, which then leads to 18k squared, 12k plus 2 plus 3k plus 2, which finally works out to be 18k squared plus 15k plus 4, and then I want to show that this is not divisible by 3. So a couple of different ways of doing it. I'm going to say that's 18k squared plus 15k plus 3 plus 1, because then I'm going to factorize this part and take 3 out. So that's 3 lots of 6k squared plus 5k plus 1, and now what I can do with that is to say, because this is 3p plus 1, 3 lots of something plus 1, that's not divisible by 3. And now I'm just going to do exactly the same for n equals 3k plus 1. Finally, consider n equals 3k plus 2, Let's go through and do the same process again. So if I do that again, we're going to get, it was 2n squared, so that's 2 lots of 3k plus 2 squared, plus n, so that's 3k plus 2, plus 1, and we'll show that this isn't divisible by 3 either. So this is 2 lots of 9k squared plus 12k plus 4, 3k plus 2 plus 1, which gives me 18k squared plus 24k plus 8 plus 3k plus 3. Tidying that up gives me 18k squared, what's that, 27k plus 11. And again, what I want to do with that is to show that that doesn't divide by 3. So that's 18k squared plus 27k. So the nearest multiple of 3 is 9 plus 2. And then this part clearly is a multiple of 3. 3 lots of 6k squared plus 9k plus 3 plus 2. So again, this one is not divisible by 3. And so if we go back there, we've completed the proof now because we've shown it's not divisible by 3 for all possibilities. You want to say that at the end. Therefore, what were we trying to do? Prove by exhaustion if n isn't, so we'll say that. If n is an integer, then 2n squared plus n plus 1 is not divisible by 3. So basically, just saying that again as my last part of my proof. With the proofs, I would always go back and just check the actual mark scheme to see whether there's any language that I've missed out there, but that's the basic technique, which hopefully makes sense to you all.